People often ask me whether it would be wonderful to go back in time. They remember a mistake, a careless sentence, a reckless decision, and imagine turning the clock back 5 minutes to fix everything. It's a deeply human wish. Regret proves we care about consequences. It proves we value outcomes and relationships. Wanting a second chance is not weakness, it is awareness. But the universe is not sentimental. It does not negotiate with regret. It follows rules, unyielding, mathematical, precise. And when we examine those rules carefully, not romantically but scientifically, we discover something unsettling about the nature of time. When you study time as a physicist instead of a screenwriter, you find no hidden doorway to yesterday. The past is not locked behind some cosmic door waiting for the right key. It is a wall, solid, seamless, built into the architecture of reality. Science begins with intellectual honesty. You must not fool yourself, and you are the easiest person to fool. We imagine time as a river we might swim upstream with enough strength. But time is not a river. It is an arrow, and arrows, by their very design, travel in only one direction, forward. Consider something simple, a porcelain cup of coffee resting on a table's edge. A small bump sends it crashing down. The handle snaps. Coffee splashes across the rug. Shards scatter across the floor. We witness it happen. But have you ever seen such an event reverse? Have you seen stains lift from fabric, liquid gather itself midair, and broken ceramic reassemble without cracks? Of course not, and you never will. Yet interestingly, the fundamental equations governing individual atoms do not forbid reverse motion. At microscopic scales, physics does not strictly prefer forward over backward direction. If you filmed billiard balls colliding and played the footage backward, the motion would look entirely natural. On that level, time appears reversible. But introduce billions upon billions of atoms, and something changes. Disorder emerges. Chaos dominates. We call this entropy, defined by the second law of thermodynamics. Entropy measures the number of possible arrangements of a system. There are very few ways for a cup to remain whole, but countless ways for it to be broken. Nature statistically favors the overwhelmingly probable, and disorder, with its vast possibilities, always wins in the long run. To reverse that shattered cup, you would need every atom, every air molecule vibrating with the crash, every photon of heat dispersing into the room to retrace its steps perfectly. You would have to reverse not just one accident, but the thermodynamic flow of the entire universe. Entropy increases relentlessly. Heat spreads. Stars burn fuel and cool. Structure dissolves into randomness. From the Big Bang's high order toward cosmic equilibrium, we are falling through time. And falling objects do not spontaneously rise. The arrow of time is written into probability itself, pointing only toward greater disorder. Still, suppose you remain stubborn. You say you don't care about entropy. You just want to travel back 10 minutes and unsay a foolish remark. You imagine a machine, a box with dials and flashing lights. You step inside, twist the controls, and emerge 10 minutes earlier. But let us examine the geometry. You believe you are sitting still right now, yet you are moving at extraordinary speed. The Earth spins, orbits the Sun, and the Sun orbits the galaxy. Space itself is dynamic. The stage beneath your feet is never stationary. If your machine moved you backward in time without accounting for space, you would reappear in empty vacuum. 10 minutes ago, Earth occupied a different position in its orbit. The planet had traveled thousands of miles. Step out carelessly, and you would suffocate in space. Space and time are inseparable, spacetime, as Einstein described. To reach Earth's past position, you must compute its coordinates relative to moving cosmic frames. But relative to what? The Sun moves. The galaxy moves. There is no absolute anchor point in the universe against which all motion is measured. Hitting Earth precisely 10 minutes in the past would require impossible precision. Imagine firing a bullet from a spinning carousel to strike a fly riding a train miles away, both in motion. The calculation lacks a fixed reference grid. Every object drifts relative to everything else. The universe offers no universal coordinate system that stands still while you jump backward. So even before paradoxes arise, the geometry alone destroys the idea. A careless time traveler would not correct a mistake. They would perish in the cold vacuum of interstellar space. Let us go further and discuss relativity. Time is flexible. It stretches depending on speed and gravity. Astronauts traveling near light speed age more slowly than those on Earth. Circle a black hole and return, and centuries may have passed here while only hours passed for you. That is genuine time travel, but only forward. The equations allow dilation, not reversal. To move backward, theory suggests exceeding the speed of light. And here the universe imposes a strict boundary. Nothing with mass can reach, let alone exceed, that cosmic speed limit. As velocity increases, relativistic effects intensify. Your mass effectively grows. The energy required to accelerate further climbs dramatically. Approaching light speed demands ever greater energy, asymptotically rising toward infinity. Infinity is not hyperbole, it is a mathematical wall. Not all the energy of stars, not the total output of galaxies, but infinite energy would be required. The universe does not possess infinite fuel. Therefore, the boundary remains uncrossed. The speed of light protects causality. It preserves the order in which events unfold and shields the past from being overtaken. Yet the most troubling obstacle is logical rather than mechanical: paradox. Nature may be strange, quantum, probabilistic, counterintuitive, but it is internally consistent. It does not tolerate contradiction. The classic example is the grandfather paradox. Travel backward, eliminate your grandfather before he meets your grandmother, and your own existence becomes impossible. If you were never born, you could not have traveled back. If he did not travel back, he survives. Cause and effect chase each other in circles. Such loops threaten the logical structure upon which physical laws depend. Imagine possessing a device that calls your past self. You warn yourself not to answer the phone. If your past self obeys, the call never occurs. If the call never occurs, no warning is given and the phone is answered. This self-negating information violates consistency. Physics cannot allow information that erases its own origin. Some propose branching timelines, parallel universes splitting at each choice. Perhaps that avoids contradiction, but that is speculation without experimental evidence. Within our observed universe, causality remains intact and effects reliably follow causes in consistent temporal order. Physics accommodates remarkable phenomena: quantum entanglement, particles tunneling through barriers, states existing in superposition. These challenge intuition but preserve logical coherence. None create true contradictions. A square circle cannot exist because the definition is self-defeating. Similarly, backward causation that nullifies itself collapses into conceptual nonsense. The universe may be mysterious, but it is not absurd. Every verified law preserves consistency across scales. Thus, time travel to the past faces not merely engineering difficulty, but conceptual incoherence. It conflicts with the very logic that underpins scientific understanding. Beyond equations lies an existential truth. We inhabit the present moment exclusively. The past is not a physical location awaiting visitors. It is information encoded in memory, records, fossils, radiation patterns. Yesterday's physical configuration has transformed irreversibly into today's entropy. We surf the advancing crest of time, never able to step backward onto the previous wave. This can feel imprisoning. The inability to undo pain or error may seem cruel. Yet this constraint shapes meaning. Without irreversibility, experience would lack finality. Actions would dissolve into revisable drafts. If revision were always possible, commitment would weaken. Decisions would lose gravity. Relationships, risks, promises, each could be edited indefinitely. The permanence of consequences grants weight to our choices. Because we cannot rewind, every moment carries singular importance. This heartbeat, this breath, this thought occurs once in the universe's entire history. Irreversibility transforms the present into something precious. It forces attention. It demands responsibility. The arrow of time is not merely a thermodynamic rule. It is a framework that gives structure to significance and narrative continuity. The cosmos itself illustrates this principle. Entropy drives stars to fuse hydrogen, radiate light, and eventually fade. Without that thermodynamic flow, there would be no energy gradients to power life. The same law that forbids reversal enables complexity. The speed of light, limiting our reach into the past, simultaneously connects us to distant galaxies whose ancient photons arrive as messages. Constraints are not arbitrary punishments. They are conditions for coherence. Boundaries shape possibility. The impossibility of going backward ensures stability in the unfolding cosmic story. Rather than wishing for a time machine, we might appreciate the architecture that denies it. Mistakes become integrated into who we are. Regret becomes instruction instead of erasure. Growth requires irreversibility. Change requires sequence. The future remains open precisely because the past is closed. We cannot revise prior chapters, but we can author the next sentence. The unknown lies ahead, filled with unsolved questions and undiscovered phenomena. Scientific curiosity thrives on forward exploration, not nostalgic retreat. Progress depends on motion in one temporal direction. So perhaps the universe's refusal to grant backward travel is not a flaw, but a design feature. The arrow of time propels us toward mystery. It preserves causality, coherence, and meaning. We move through an ever-advancing present, writing reality in permanent ink. That permanence gives depth to joy and seriousness to error. We cannot return to earlier pages, but we can shape what follows. The cosmos permits only forward motion, and within that constraint lies freedom, the freedom to act now. The script continues, and it is ours to extend.